What is this suspension? So in the previous class, we were discussed about suspension. And what is this suspension? Suspension is what? It is a heterogeneous mixture. Suspension what? It is a heterogeneous mixture. Right? Suspension is a heterogeneous mixture in which every fine particles of solid, every fine particles of solid, fine particles of solid are dispersed in any medium. Any medium means, what are those any medium? Either liquid or gas. Liquid or gas. Okay. So here the suspension is what? It is a heterogeneous mixture in which fine particles of a solid are dispersed in any medium and remain suspended in the medium. That is what we used to say, that suspension. Then what are the properties of this suspension solution? What we are discussing here is all are the types of solutions. What are these? These all are the types of solutions. So here, now we will discuss the suspension. What are those? Heterogeneous mixture in which very fine particles of solid are dispersed in any medium, whether liquid or gases, and remain suspended in the medium. Can be visible there. Okay. Such solutions, that what we used to say, that suspension. Then what are the properties of this suspension? Okay. So we will discuss now properties of suspension. So first, nature of them and visibility. Okay. So properties of suspension. Properties. So then first, the nature of the suspension. First is what? Nature. What is that nature? Heterogeneous. The suspension are what? These are heterogeneous. Heterogeneous mixture. Right? It is a property of the nature of that suspension. The next property is visibility. The next property is what? Visibility. So whether in the suspension the particles are visible or not visible, the particles are visible to naked eye. I told you while discussing the definition only we come to know that the particles are dispersed in any medium and then those are visible. How we come to know? Those are suspended in the medium. Okay, those are suspended, remain suspended means it is visible to the naked eye. So here visibility is what? The particles are visible. Particles are visible to naked eye. Okay, particles are visible to the naked eyes. Okay, then scattering of light. In this solution, is it possible to scatter the light? Okay, scattering light. Is it possible? The solution, that is what in suspension, is it possible that the light can scatter through that solution? Yes. So here the particles scatter a beam of light passing through it because already those particles are suspended in that medium and it is visible to our naked eye. Obviously, if the light should pass through in any medium, what are the material medium are helping that? In vacuum also it is possible to travel, light can travel in vacuum also. and in our surrounding, just look at that, in the room, even a small light pass through that, if there is a small slit, or you can see that window is open, how that light pass through that, and we can see that the dust particle in that part of that light, right? So here, in the same way, well, that is what suspension. Those particles which are present in the solution, which is prepared, and what we are going to say that the mixture, which is of heterogeneous. Air is also heterogeneous or homogeneous? Is heterogeneous. So here, the light allowed to pass to them, those particles make them scattered. The particles helps to scatter that beam. So it is possible in the suspension. So write on here, scattering light. Particles scatter beam of light. Particles scatter beam of light passing through. Particles scatter beam of light passing through it and makes it path visible. Passing through it means what? Suspension or mixture, and makes the path visible and makes its path visible. Visible. That is what we used to say that. So the third property, scattering of light, is also possible in suspension. The next property is sedimentation. What is that? Sedimentation. We heard that sedimentation means what? The insoluble substance are going to settle for a longer. We had seen that sedimental matter, sedimented particles. What is this sedimental? They are going to settle on the surface of those substances. Okay, they are going to settle there. Such material, that is what we used to say that process sedimentation. Whether its properties apply to the suspension. So here, the sedimentation is what? The solute particles settle down when suspension is left undistributed. So whatever those particles in the mixture of suspension, they left undistributed. Those substances are not going to distribute it. Those particles are going to settle down. I told you, what is this sedimentation? Sedimented means what? It is going to settle down. Right? And even in ocean we are going to observe some stones with on that some metals are going to, some substance are going to cover the layer of those particles we can see. Those what we used to say that sedimentation. Even if we consider the sand into that water or mud, if you consider, it will not, the some amount of the mud will settle down. It is not going to distribute at all and not going to dissolve. So it is going to settle. Such type of particle we used to say that process, that is sedimentation. So here what happens? Those particles which are left undistributed, which particles are not distributed thoroughly in that solution, those are going to be settled down in the solution, that is suspension. Okay, write down here, solute particles settle down. Solute particles settle down. Solute particles settle down when a suspension is left. When a suspension is left undistributed, that is, what is this undistributed? That is, suspension is unstable. Suspension is unstable. So here another property, when the solute particles are going to settle down when that suspension is undistributed. Okay. The next property is filterability. I told you filterability is what? This sedimented solution can be filtered, can be separated by using filter. Okay, which one is undistributed particles are there? They are going to be separated by filtration. So next property is filterability. Filterability is the process just a minute. So filterability is another property. Particles can be separated. Particles can be separated by filtering. Okay. Particles can be separated from the mixture by filtration or filtering. Okay, can be separated by filtration. Separated from mixture. Separated from mixture by filtration. Okay, just to understand, here I am giving one example to you, that is just for understanding. Okay, you could have seen that when we are going to filter that tea, right, the tea leaves are remained in the solution. Okay, when we are going to filter, the tea leaves are going to separate. It is just for understanding, not the example for this. Okay, so here example for these are the suspension of magnesium hydroxide in water. The suspension of magnesium hydroxide in water. That is what? The another name of this is milk of magnesia. We used to call it as milk of magnesia. So here that milk of magnesia, so when the substance, the particle of those magnesia, it is going to be remain, okay, separated, can be separated by the help of filterability or filtration. The another two properties are there. Another property, that is transparency. So what about the transparency of this? Whether these suspension are transparent or not. So that is what the another property, transparency. What do you mean by transparency? If we are going to observe with the help of that media, it should be seen clearly, right? That is what we used to say, that transparency. For example, glass is a transparent medium. Right? So here the transparency, suspension are either opaque or translucent. Means here these are transparency. So we can see that solution, or we can, with the help of that, through that solution, anything can be seen clearly. That is what transparency. Translucent means what? The blur, not clear picture is going to be seen. Those objects we used to say that translucent. And opaque, we know that not allowed to pass through that light, so it is not possible to see the object behind that opaque object. So they are going to give hurdles to that object. For example, wood we are going to consider as opaque, okay, and some oil patches of papers or tissues are the translucent, and transparent we can take as a glass. So here this suspension, either it is a opaque or translucent, means this is transparency solution. Okay. So these are few properties of suspension. Okay. So for example for suspensions, examples: milk of magnesium, milk of magnesium, that is how we are going to write the suspension of magnesium hydroxide in water. Suspension of magnesium hydroxide in water is known as milk of magnesia. These are examples for suspension. Okay. Then another example for suspension is lime water. It is lime water. What is this lime water? Suspension of calcium hydroxide in water. Suspension of calcium hydroxide in water. Okay. Then another example for suspension, that is muddy water or paste. Before only I have taken the example, that is muddy water, right? Where the particles are going to settle down. Okay. Muddy water. Right? So here, suspension of substance in water or some other liquid. Okay. Suspension of substance. Here which substance we are considering? That is muddy. So here suspension of substance in water. Okay. That is what? Muddy water. These are few examples for suspension. So what is this suspension? It is a heterogeneous mixture in which every fine particle of a solid are dispersed in any medium and remain suspended in the solution. So okay, these are going to disperse in medium, but they are going to settle down in that medium and remain suspended. Those are called suspension. Okay. These are properties and example of suspension. The next type of solution is colloidal solution. Okay. Next type of solution is colloidal solution. This is colloidal, C-O-L-L-O-I-D-L, colloidal solution. What is this colloidal solution? It is also a heterogeneous mixture in which the size of particle lies between those of true solution and suspension. True solution and suspension. We had studied that the solution, true solution means what? Almost dissolve in the solute is going to dissolve in that solution. Okay. So here these colloidal particles, they are going to lies between true solution and suspension. We come to know that suspension means what? The heterogeneous in the mixture. Whatever the particles are there, they are going to disperse, but they are going to settle down. It is a suspension. Then what is this true solution? True solution is what? The particles of solute are thoroughly mixed within that solvent. What type of solvent is there? In that solvent, if solute is thoroughly mixed, that is true solution. So here, this colloidal solution is what? It lies between true solution and suspension. Either the solution is thoroughly going to mix, that is true solution, and the substance is the particles are going to disperse in the medium, but they are going to settle down in that medium, that is suspension. So in between either true solution or suspension. In between true solution and suspension, the colloidal solution lies. So what is this then? What is the meaning of this colloidal solution? How to define? So here the particle lies between true solution and suspension. Usually this colloidal system has two-phase system. The colloidal solution is of two-phase system. What are those? One is dispersed medium, another one is dispersed phase. Dispersion medium and dispersed phase. These are the two systems of solution of colloidal solution. Dispersed medium and dispersion phase. Okay, dispersed phase and dispersion medium. And here in the colloidal solution, a very tiny and small material that is spread out uniformly all through another substance. See, why this colloidal solution lies between true solution and suspension? Because here in colloidal solution, whatever the fine and tiny particles are there, they are going to mix with another substance. They are going to mix thoroughly with the another substances. So write on here, what is this colloidal? It is a heterogeneous mixture. It is a heterogeneous mixture lies between, in which the size of the particle lies between a true solution and suspension. Right? So here the size of the particle, it is visible to the naked eye. Right? In true solution, in the suspension we studied that the particles are visible to the naked eye. But what about in true solution? It is going to mix thoroughly. Means those are to be not able to visible in the naked eye. So here this colloidal, those particle size of those particles lies between true solution and suspension. Okay, so here this colloidal system is of two-phase system. Okay. Before that, the fine and tiny particles, a colloidal is not colloidal. A colloid means what? A colloid is a tiny or fine particle, is a tiny or small material that is spread out. Tiny or not fine, tiny or small material which is spread. It a tiny or small material which is spread out uniformly. Which is spread out uniformly all through another substance. Spread out uniformly all through another substance. Okay. So here this colloidal system has two-phase. The colloidal system is a two-phase system. Colloidal system is system. What are those two-phase system? One is dispersed. One is dispersed phase. Dispersed phase. And the second one is dispersion medium. Okay. So here this colloidal system is of two phase, dispersed phase and dispersion medium. So what is this dispersed phase? Dispersed phase, the components of colloid present in small amount. The component of colloid present in small amount, and it provides the medium in which it is going to resolve. Okay. So here dispersion medium is what? Medium in which colloidal particles disperse or suspend themselves. Dispersed or suspend themselves. That medium is to say that dispersion medium. And here the components of colloid. That is dispersed phase. And in which medium it is going to disperse, that is dispersion medium. Yes. So at this point we will conclude this concept, and remaining we will discuss in the next class.